All right, hello again. So in this video, we're going to talk about loops, which is going to be a major control structure that's used inside of Python. It's a way for us to be able to do stuff over and over and over again. This video is going to mostly be sort of reiterating or rehashing the examples from the course text, but I'm hoping that by sort of walking them through verbally, that can help clarify how some of these pieces end up working. There's not a lot of other new information in this other, it's just sort of examples. All right, so we're going to talk about loops. Loops are a process for doing iteration. It's basically a way of doing the same thing over and over and over and over and over and over and over again. This is what computers are meant for. Computers, like the best thing that computers can do is the fact that they can do the same thing repeatedly without getting bored or tired or normally making these sort of mistakes, right? They can just keep doing the same thing repeatedly over and over again, and computers are great at that. They're so much better than people, which is why loops are a big part of what we actually want to use computers to do. They're part of what makes computers really important. All right, so there's a couple different ways we can do loops in Python. The most common kind of loop, the way we're going to do loops in Python, can I move this thing up? I can. The most common way we're going to do loops in Python is by using what's called a for loop. It's called a for loop because we're going to use the keyword for to write this thing out. A for loop is basically going to be a loop that's going to take a sequence similar to a list or a range or a string, and it's going to execute a block of code one time for each element in that sequence. So you can almost think about saying like for each thing in the array, in the list, for each thing in my list, do this code, run this block. Your general syntax, you're going to write it out as saying we're using the keyword for. You're then going to define the name for a local variable, so it's going to be a thing you define, in some sequence of interest, followed by a colon, so a block, and then you've got your indented lines of code that you actually want to run. And again, the way this is read is saying that for each item, and we're going to refer to that current item as a local variable that is in the sequence, then we should do the lines of code to do the stuff. Okay, let's see what this looks like in practice. Let's actually just pop over to Jupyter. I'm going to move my little thing back down in the corner. Great, so here's an example. So I have a sequence. This is a list of numbers, 1, 2, 3, 4, 5. I could have used a range, but I'm using a list because it's a little bit cleaner about what we're doing on. So the way we might write that is I'm going to say for each number in my numbers list. So the idea is I'm going to go through each one of these values, the 1, the 2, the 3, the 4, and the 5, and whichever one I'm currently on, the thing that I'm actually dealing with at the moment, I'm going to refer to as the number, as number. So the fact that I'm using this word number is not special, it's just a variable name in order to sort of put these pieces together. So what I'm going to do is I would say take my numbers list, go for each number in my numbers list, and then I can say that for each one of those things, print out the current number, the thing that I'm actually dealing with. And if I do this work, you'll notice that it prints out the numbers 1, 2, 3, 4, 5, all in their own line, because again, it's going to go print out each one of those pieces. I can, of course, do some modifications to this. If I want to say, take that number, convert it to a string, and then add an exclamation point at the end, I can then be able to print out all the numbers with exclamation points, so it's now an exciting thing in order to do that kind of work. So again, hold on, pause 1 second. Yeah, so what's going on here is that every time I go through this sequence, or every time I go through that list, I'm taking whatever value I'm currently in, and Python interpreter is implicitly assigning that item to whatever this local variable happens to be. So that when I go to my numbers list, we're going to take this 1, and when we start my loop, I'm going to take my 1, I'm going to assign that 1 to the value number, then I'm going to execute this block of code, and I'm going to print out the string of 1, adding my exclamation points to it. Once we then get to the end of that block, my code then loops around back to the top. I'm going to then go to the next element in my sequence, the 2, assign that to number, and then be able to do my block. Once we get to the end of the block, we're going to loop back around, and that's why it's a loop, because you're sort of making a cycle. Grab the 3 gets assigned a number, we're going to print out that number, we swing back around, we're on to the next value, which is the 4 gets assigned a number, we're going to do our work, swing back around, finally the 5 gets assigned to, we get to the next value, the 5 is assigned a number, we print it out, we then loop back around, we are now out of values in our sequence is empty, so then our code moves on to the end, and we can now say we're done, right? Print out that we are now done, right? That happens after my loop is finished and after we finish going through all these pieces. So again, loops are very much about saying, do this thing over and over again one time for each element inside of my sequence. So currently we're doing something fairly simple, right? We're just printing out a single thing inside my block, but it's actually possible to do much more complex stuff inside that block. So a block is the same thing we'd use inside just like a block in an if statement or just like a block in a function. We can include lots and lots of lines of code and actually do lots of fairly complex things. So what I'm going to do is I'm going to first change here. Hold on a second. All right, so I've done some quick adjustments. So I'm going to change my numbers list, again, numbers, still plural, to be a list of slightly more complex numbers, ranging, just so we have a little bit more variety to work with. We can then have a loop where we'll go for each number in my numbers list. And again, it's the exact same structure. Notice singular, plural, right? That's part of why this makes this really significant, right? Am I dealing with one number or am I dealing with all the numbers, right? The whole list of numbers. That's we need to keep track of that. And then inside this block, I can do something like say, let's look at that number and I can compare it to 5. And if so, I can say it's big, and otherwise I could print that small. If I execute this code, I get, oh my gosh, I'm still in Python. Oh my, wow, I can't believe I didn't get caught. You ever make mistakes on live TV? I do it all the time. Not live, it's recorded, whatever. Great, so this is in case we're going to go through. We're going to say, let's take the 5.21, assign that to number. We say, is that bigger than 5? It is, so we're going to print out is big. We don't do the else. We get to the end of the block, loop back around. We're then going to go to the second value, the 8. We say, is that bigger than 5? It is. Keep going until eventually we're going to get to the 3.27. That's not bigger than 5, so that gets into an else. Again, we're going to looping back around, and that's going to be able to get us through all these different pieces. We can do all these different kinds of examples. Great. All right, so for loops are, again, the cycle is sort of just going to go around and around and repeat some block once for each element in the value. Because you're doing this repeating work, and because those couple lines of code that are inside that block might end up executing over and over and over again, right? They're going to execute once for every element inside your sequence, you need to be careful a little bit when you start dealing with things like variable assignment or declaration inside of those lists. So here's an example. So our task here is that we're going to try to basically tally up how many different big numbers are in my list. So I might say, okay, I got a bunch of numbers and I want to know how many of them are big. And by big, I mean greater than 5. As humans, we can look and say, oh, that's 1, 2, 3. Like we count this up, right? We say that's 1, that's 2, that's 3, that one's smaller, that one's too small. Okay, great, we got 3 total. I've got 3 tally marks, so therefore that's how many big items are on my list. So we can do this kind of thing. Notice this example is not going to work. I'm going to show you a broken version and we'll show you how to fix it. So what you might think to do is I'm actually doing that tally work. We might say, okay, great, well, let's come up with a tally, right? This is going to be how many fingers I'm holding up. And we're going to start off with 0 being held up because I haven't counted any values yet. So then we're going to then say, okay, great, if the number is bigger than 5, then I'm going to have my big number tally go up by 1, right? So when we get to the 5, it should go up by 1. When we get to the 8, that should go up by another 1. And then in the end, after I'm done doing that, I should then print out what my big number tally is. That's sort of the logic we're going to try to think through. So literally, I'm just basically keeping a variable. There'll be a number. There'll be like how many tally marks there are at the moment. If I execute this code, you'll notice that it didn't print out 3, which is the number of big numbers I expect there to be, because that's what we got when we did it manually. Instead, it printed out 11100. Wait, what's going on here? There's a couple of pieces that cause this to break and not to work. So part of the issue here is that every time through the loop, this line of code executes. So if we say that here's my tally, right? My tally is my fist that has this many fingers. Then we say, great, we're going to get to my first number, 5.21. My big number tally goes to 0. I see if it's greater than 5. It is, so therefore my big number tally goes up to 1. I print it out. There's my 1. We then loop back around. We get to my 8. 8 is now my number. My big number tally is equal to 0, which means I'm going to take that finger and I'm going to put it down. It's like I'm erasing my tally marks every time I get to the next thing. I'm going to basically be forgetting the tally mark that I was doing. I then see if the 8 is greater than 5. It is, so my tally mark increases by 1. I printed it out. I swing back around. Get to the 10. The 10 is my number. My big tally mark goes back to 0. So again, I keep erasing the fact that I've made these tally marks because I keep basically like getting a new sheet of paper every time I want to count up something new. So what that means is if you want to have some value that's going to need to basically be persisting or remembering or counting changes that are going to happen across a loop, sort of over the length of it. So it's going to basically need to remember that value for every different number as it goes through all these pieces. You want to make sure that you take those variables and you're going to declare them outside of the loop. So you're going to want to basically say, great, let's start with having my big number tally be 0 before I even start looping. And then as I'm going through and doing my loop, then I'm going to keep modifying big number tally, but I'm not going to be ever reassigning it to 0 because I've only assigned it to 0 once before the loop actually began. If I now execute this line of code again, you'll now see that it counts 1, 2, 3, and then it just keeps printing out all these values. The reason, again, it's doing that is because I'm printing out the value every time I finish counting. So it's like saying count 1 and then shout out your tally, count 2 and shout out your tally, count 3 and shout out your tally, which is probably not what we're really interested in. So again, if we want to then say, let's assign the value, the thing we're interested in, this tally, outside of the loop, we can then do our loop to figure out what we want that tally to be. And then after that loop is finished, then I can go and saying, great, I'm now done doing my loop. I'm done counting up my numbers. Now I can print out what the actual final result ends up being. And when I do that work, I now get printing out my big number tally, which is 3, which is the value that I actually wanted to care about and the thing that I actually wanted to be able to use. Okay, resetting again. So that's the basic idea of how you would loop through lists and how you sort of deal with those kinds of pieces. But I want to note that lists aren't the only things we can loop through. We can, of course, also loop through any other sequence. So I can loop through a range, for example, and we'll do this fairly commonly. So I might say, let's go through my range of values from 0 to 10, excluding the 10, remember. And I'm going to call each one number, and I'm going to print out that number as we go. So again, this is going to look exactly like the previous loop that I just had. I'm going to print them out, and that's going to print out my values from 0 to 10. And so we do this. This happens a lot. The reason this happens a lot is because we end up using ranges in order to help us loop through lists. And the way that we're going to do that is that we use a range when we want to loop through all of the indices of a list rather than looping through all the values of a list. So the thing that we had previously, let me go grab that back in. So the thing that we had previously, not up there. Is that this would say go through every value, right? 1, 2, 3, 4, 5 inside my numbers list and print out those values. But if this was a set of strings, let me make the string real fast. Sorry, I didn't have this prepped quite as nice as I should have. You're not a list of numbers. You are actually now a letters list. Letters. I should pre have done this. Sorry. That if I want to then say like, well, okay, I want to be able to go through all these different letters. If I want to modify them, or if I want to basically refer to who lives in those spaces, what I want to potentially do is actually loop through not the people who live in all the rooms. I don't want to say go through all the different residents in my hotel. I want to actually say let's loop through and let's go through all the different room numbers in my hotel, and then I can be able to talk about the room itself rather than the person who lives in that room. So there's 2 steps to do that we're going to do in order to sort of make this work. The first thing that we're going to do is that we need to basically say that, keep in mind, remember the fact that if I want to go through a list of all my rooms in my list, then that means I really want to go through the room 0, 1, 2, 3, 4. So it basically means that I want my sequence of things that I want to loop through to be 0, 1, 2, 3, 4. Well, if I need a sequence of 0, 1, 2, 3, 4, that's just a range, right? That's easy to put together, right? So I could have a range 4, and that's going to give me in my sequence 0, 1, 2, 3, 4. That 4, though, the reason I got that 4, you'll notice, right, except I want 4 to be inclusive, so I actually need a range of 5, right? Now that'll give me 0, 1, 2, 3, 4, because the 5 is exclusive. The place that 5 came from, as you'll remember, was the number of items, the number of rooms I had in my hotel. So the way that this often gets written is if I want to basically say my list indices, right, instead of just saying it's going to be a range 5, and then I can print out my list indices so you can see what it looks like. Then instead of just saying it's going to be a list 5, what I'm actually going to do is I'm going to say that it's going to be a range from 0 to whatever the length of my list happens to be. So I'm just going to basically I'm going to start nesting in some function calls. So I'm going to say, let's get the length of my list, which in this case will be 5. It's a number of elements inside of it. And then I'm going to say, great, I know there's 5 rooms total, so now give me a sequence of values that's going to be 0, 1, 2, 3, up to that number, up to 5. And that becomes my list indices, which I can then be able to, oh my gosh. Sorry, I need to actually run this code. Top. There we go. And that'll actually give me then my range from 0 to 5. Once I have that list indices, I can then go through each index in my list indices, which again, think of it as like going through each room number, and then I could do something like print out, and I think I might even have a shortcut on this. Yeah, I'm just going to paste it in the book. And then I could do something like I could say print out the value at that index to say that it is going to be from my letters list, which will be whoever lives at that index. So again, the way this is going to do is I'm going to go through my values 0, 1, 2, 3, 4, 5. I'm going to take the index, which is the room number, the 0, and I'm going to say the value at that index, at that room number is, and then I'm going to use that index, that room number, and say that I'm going to refer to whoever lives inside that letter list, and I'm going to put that value, that 0, inside the bracket in order to say that the person who lives at room 0 is this particular letter. So if I run this block of code, you can see that it tells me that the value at index 0 is an A, at 1 is a B, 2 is a C, 3 is a D, and 4 is an E. It loops through and will actually let me reference and refer to each individual piece sort of as I'm going. This sort of process overall works okay, right? We can sort of do this kind of work. Basically say, let's give yourself a list of indices, loop through that list of indices. More commonly, you'll sort of skip making this intermediate variable, and you'll just take this range, and you're just going to, again, replace the alias with the actual value itself. So you would then say loop through all the indices in my range of indices from my letter list. So if you ever see this in range len, that basically says loop through the room numbers of the hotel, not through the people who live in the hotel. So we're not going through the residents, we're going through the room number, right? So I'm going to talk about each room number rather than talking about each person who happens to live there. So this distinction between index and value ends up being really important when we're doing this kind of work. Okay, great. So it's worth noting, why did I delete this? I'm not sure why I deleted this kind of thing. Let me just get my numbers back here again. So there's my numbers. So I can loop through for num in range len of numbers. Right, this is probably what my examples that I want to paste in were actually about. I can loop through all those different numbers, and I can say print out the number that I cared about. That's fine. Right, again, printing out the number is not printing out 5.21, 8, 10.8, 3.27, or 3.98. They're printing out the indices, right? This is actually, so it's really not a number. A better way of framing this is this would be my index, right? Or my current index. Is we really want to be careful about whether I'm talking about the number, particularly when dealing with lists of numbers, or the index itself. Great, so once I've got this index, I can actually then use it to modify my list as I go. So if I have a set of numbers, and maybe I want to go through and I want to round all the values of this list, what I can then do is I can say, okay, great, let's get the resident, right, is the person who, the resident is going to end up being the person in numbers who lives at that index, right? So basically say we're going to go up to room 0, we're going to knock on the door at room 0, and then Bob, 5.21 opens the door. We say, hey, 5.21, we're going to grab him, he's the resident. I can then produce a rounded version of the resident by calling the round function for resident, right? So basically I'm going to grab 5.21, so we grab Bob, we pull him out, we're going to then shape him, we're going to round him so he looks a little bit better, and then I'm going to take that rounded version, I'm going to put it back inside the hotel room, basically reassign it so that now there's a rounded version living there. It's almost like taking someone, making a cleaner copy of themselves, and pushing them back into the room. So I can do that by saying, let's go back to numbers at index 0, right? So we're going to say, go back to room number 0, and we're going to put rounded guy inside of there. So the process here is, again, access the element at that index, modify that element, and then take that modification and put it back inside the list. If I do that work here, then what you'll then notice is that if I then print out numbers at the end, then now it's going to print out all those values, 5.21, 8, 10, 3, and 3, and 4, rounded using the round function. And that's basically how you can then be able to say, I want to go through, I want to modify everybody in my list. This is technically referred to as a mapping operation. We'll actually talk about other ways of doing this kind of work later, but this is sort of your basic, like, how do I change everybody inside of the list? You can't change people without going through the room numbers, because what would happen is if you went through all the values, and I might grab Bob, I grab 5.21 and say, hey, 5.21, I'm going to make a newer, cleaner version of you, but I can't put that cleaner version back into the hotel because I don't know what room number I grabbed it out from. Like, the Python interpreter knows that it's going through the loop, but at any given stage, like when I grab the 3.27, I don't know if that's going to be from the early part of the hotel, the later part of the hotel, I don't know where it happens to be, so we need to be able to keep track of that index if I want to be able to modify the elements as I go. I will note that this is sort of a roundabout way of doing it because I'm trying to walk through the individual steps. We could speed this around, we could sort of tighten up this code if we wanted to, so we might say that, okay, this resident is numbers index, so let's take where we use the term resident and let's just replace it with numbers index. And let's just skip out that middleman. Similarly, I might say the rounded value is this thing, so why don't we just get rid of that rounded variable itself, and I can just be able to go ahead and change it as well. And then you can get sort of the one-liner version where I'm going to say take the value, numbers index, modify it, and put it back where it came from. And then again, this produces the same result when I end up running the whole code. Okay, there's one more thing I wanted to go through in order to talk about for loops and how we use them. In particular, this is an example of what I want to call is called a nested loop. So remember that inside of a for loop, inside of that block, right, the thing after the colon, I can put any set of content, any set of code I want. I can put assignments, print statements, method calls, or function calls. I can put if statements. I can even put other loops. And we'll do that occasionally, not often. It is not common, but it's a thing that we will do, particularly when we're dealing with larger data sets. It is possible to have a loop inside of a loop. So again, the way this is going to work is I'm going to have a for loop where I'm going to say, let's go through every letter in A, B, and C. And again, I'm not going through my indices at the moment. I'm just going through the people who live in the hotel. I don't care about the room numbers they're in. And then we might say that for each one of those letters, we're going to then go through the numbers 1, 2, and 3. And then for each of those numbers 1, 2, 3, I'm then going to print out my current letter number combination. So I'm going to output this. We can see what it looks like. So what this is going to do is basically going to print out these letter number combinations. So the way that we read this code, the way that we think about this running, is we say, great, the Python interpreter is going to say, okay, we're going to do my for loop. I'm going to take this A, my first element, and I'm going to assign A to letter. So at the moment, letter is A. So right here, we've got letter is currently A. Now that letter is A, I have to execute the entire body of this loop before I can have my letter move on to B. So now I say, great, my letter is A, so I'm going to execute the next loop. So it's almost like we're forgetting that this thing existed, and I'm only going to think about now the stuff that's inside that loop. So great, my letter is A, and now I know that I want to go through every number, 1, 2, and 3, and I want to print out the letter A and that number. So we'll do that work. So we're going to print out A1, then we print out A2, and print out A3. Once we finish this inner loop, right, we finished going through it 3 times, 1, 2, 3, then now we're down at the end of the block, and so what's going to happen is our interpreter is going to loop back around, because it's going to finish that loop, so it gets outside of this loop, so we now get to the sort of the done with inner loop step. Now that we're done with the inner loop, we're going to loop back around to my outer for loop, moves on to the next thing, the B. B gets assigned a letter, so my letter now becomes B in effect. And then we're going to execute the whole block again. So we say, oh, great, my letter is B. Oh, but I have to do this inner loop instead. So now we're going to go through and say, great, now I need to go through 1, 2, and 3 to print out B, 1, 2, and 3, and I get B, 1, 2, and 3. We then finish with the inner loop, which means that we then loop back around to the outer loop. We're going to go to C, repeat it again, go through C, 1, 2, 3, and then eventually we're going to get to be done with the outer loop. And then I can print out that we're done, all done, and then we actually get our all done thing at the end. So the way that these nested loops end up working is that we end up sort of doing one thing from the outer loop and then doing all the things in the inner loop, and then doing the next thing from the outer loop and then all the things from the inner loop, and then doing the next thing from the outer loop and then doing all the things from the inner loop. The thing to note here, and part of the reason that you need to be careful when you're in nest loops, is that in terms of, there's only, in this line of code, there's only one print statement, right? I mean, there's the one all done, but ignoring this all done thing here, there's only one actual print statement. Yet we printed out 1, 2, 3, 4, 5, 6, 7, 8, 9 different statements. There's 9 different lines of code that we printed. This thing here inside the loops ran 9 times. It ran 3 times for the numbers for each of these 3 letters. So this is run 3 times 3 times in order to print out these 9 different values. When you nest loops, things are going to happen a lot, repeatedly, right? This is 3 and 3, but if I was trying to do something like, say, had a for num in range 0 to 100, and then inside of that I wanted to do for num2 in range from 0 to 1000, print num, I do not want to execute this code because this is going to run, the inner loop will run 1,000 times for each of these 100 times, which means it's going to run 100,000 times, and that's going to print out a lot of numbers, and that's not something I want to do. So you want to be really careful when you're using a nested loop. In practice, for most of the stuff that we're going to do in this class, you don't need a nested loop unless we really we'll sort of let you know if you need one. I want to show you how they work because they will show up a little bit, but in general, think about trying to work with sort of individual single loops. Don't try to nest things together. Like, your instinct should not be to have lots of fors. It should be instinct to have one for that says, let's run through one thing one time. Okay, but why am I going over these anyway? The reason we go over them is because these get used for things like tables, when we have nested loops. So if I have when we have nested lists. So if I have a nested list, it sort of goes along that I'm going to end up wanting to then use a nested loop. So imagine we have a data table here, which is going to be my list of lists. It's similar to like my food options table. In this case, I'm just using simple letters just to sort of like keep things track. So in this case, all the first row has all the values starting with A, where column 1 is going to be 1, 2, 3, 4, and then column B is going to be row B, there's the B row, and then I've got the C row, and then I've got sort of 1, 2, and 3 columns. So you can sort of read this as a table, and it gets actually written out just fine as a nested loop. So there's my table. If I go ask what this table looks like, it ends up looking like that same kind of structure, and everything works fine. It's okay. Okay. So if I want to then loop through this table, if I want to say, like, I want to print out every value from this table, I want to say, like, look, or I want to consider every individual value, what I would need to do is I would say, okay, great, I've got this outer loop, right? I've got this set of rows, so I actually need to loop through those rows. So what I might do is I might say, let's go through each row in my table, and then for each one of those rows, right, those rows then have these 4 different columns, these 4 different values inside of it. So I might then say for each column in my row, right? Because remember, my row is going to be in a list, like this guy. And so I can grab each element of that row. And then I might say, let's print out the table. Let's print out then the column. Let's print out where that column, like who happens to be at that column, right? What's the value? So it might be a little bit cleaner, actually, just refer to this as value. So you might say, let's print out the value of that row, and that will then print out my entire table, row, column. This can, of course, get slightly more complex, and if we want to modify these kinds of things, we might do so by using by looping through the indices instead of looping through the actual values themselves. So, for example, maybe I want to talk about going through the row index in my range from my length of my table. Right. Remember, there's that range len thing that's going to let us be able to loop through all the room numbers, of which there are 3, right? Room number 0, room number 1, room number 2. So you can think of those as looping through the row numbers. So it's going to be what my row number is. And then I can think about, let's go through my column number by saying by taking my individual row, and then I'm going to actually be saying, let's go through and get the range for my length of my row. So we're going to go through all the the room numbers in my row, so that's going to be 0, 1, 2, 3, so that's my column index, and then I can actually print out to say who lives in my table, who lives at my row index, right, which is going to be this list, right, which list am I at, and then because that's a list, I can then use that secondary bracket thing that we talked about with our nested lists to be able to then say who lives at my column index. Oop. Close parenthesis, and then we get the same kind of result. Yay! Right, we just did the same work, but now we can keep track of what row and where column we happen to be in. This can, of course, let us also be able to do things like start doing modification work. So, for example, I can then say, let's take my table row guy, and I can do something like, let's go ahead and assign a new value to it. Let's replace this with let's swap the letters. Let's replace it with my call index, which is going to be let's replace it with itself. I'm not trying. Add exclamation points. Those are easy. Plus exclamation points. Right, is I can then take that element and I can modify it, similar to how we did rounding previously, in order to then reassign it back to that table. If I do that work and then I ask to print out what my table looks like, my table now has all the same content with exclamation points all over it. So when we're working with tables of data, which we'll do more and more as we get through this class, because this is sort of, in theory, a data science-y centric programming class, we may be using some of these nested loop type structure, but if you're not dealing with a table, if you don't have nested lists, you don't need nested loops. That's the really important thing to remember. Only deal with nesting for loops if you actually have a nested data structure, a nested sequence to work with. Okay, I think that's the basics of for loops, sort of quickly. I feel like I might have forgotten some details or something note, but I think I went through all the stuff I had in the book and in my notes, so I think that's everything. If I forgot something, if something's missing, let me know, and I will happy to add clarification and potentially record an addendum video if I have to and make that work.